Okay, so today I'm going to do an experiment today with an air gun and a nail, and I'm going to be using momentum to try to find the speed at which I shoot the nail. So I'm going to pump this air gun up to 40 psi, and then I'm going to shoot the nail, and I have a swinging mass behind here. You can come in a little closer. I have a swinging mass right here, and so the nail should hit the mass, and then back here there's a measurement. I have this put up so it's all leveled it all out, and then it just shows how high the mass will get after that, after whatever height it gets. So this is the video of my experiment when I shoot the mass with the nail. And one of the things I didn't go over is that there is a metal piece of sheet metal on top of the mass, and then the nail is also metal. So that's me trying to make the collision elastic. Okay. And so here's the video. And then I'll try to pause it at the max, so right around there. And so here. So as you can see, this, it's kind of hard to tell, but right here is around 5 centimeters, and you can see the little indicators right there. And then at the top, I think it's around like 6, 7. The top is 9. At the bottom it's 7, so I took the average. I took this spot right here in the middle, so I used the height of 7 centimeters for my value, because the center of mass is at 7 centimeters tall. Okay, so now that we found the height that our mass swings up to, we need to find some other variables. So I need to find the mass of the nail we shoot, and it should be around 10 grams. 10 grams. And then we need to find the mass of the object we're shooting, which should be 568 grams. Whatever, 568 grams. Okay, so now that we found the mass of the dart we're shooting and the object we're going to hit, and we know the height that the object swings up in the air, we should be able to find the velocity that the dart is coming out of the barrel at. So I'm going to start off this with the first equation, which is the conservation of momentum. So we can do the mass of our dart, and then our mass of our object goes to 0, and then the final mass of the dart and times the final velocity, and the mass of the object times the final velocity of the object. So then I plugged in numbers, and we needed to find the final velocity of the object, and we can do that by plugging in our height into another conservation of energy equation, which shows up with the pendulum. So then that gives us, at the bottom, the object is going 1.17 meters per second. And then so after I have that, I can plug the velocity of the object into this equation, and I get that equation. So next I'm going to do another, I'm going to use the simplified conservation of energy equation. And so I can do V initial plus V1 initial plus V1 final equals V2 initial plus V2 final. And by plugging in our final velocity for the object we are shooting, up that gets hit and goes up in the air, plug them there, and then we can add the two equations together, and we find that our final velocity of the dart is 33 meters per second. Okay, so now that I've gone over the equations and everything else, I want to go over some of the flaws my experiment has, so probably why the numbers aren't exactly accurate. So first off, the collision we have is not exactly elastic. I'm using two things that aren't compressed, but after shooting the metal a couple times, you can see little indents that the nail left. And so all of these are spots where I waste energy, and energy is absorbed and it is not going into the block, making it swing up. Another part is the tip of the nail is a little flattened because of the energy is lost in that process. And another thing is when I saw how high the mass swung up in the air, it would be easier if you had a mark right at wherever that showed you where the center of mass is. But because my block is curved and it's not exactly proportional where all the mass is, so I just used a center mass point, which is like right in the center right here. But realistically, because it is bowed and it is not exactly even, the center of mass can be a little bit off from that point I used.